a.m. and hot dog. It's a crazy smoky day outside in Regina. That's actually irritating my eyes today. Anyways, and this is Chemistry in the AM. We are joining in progress. You can't see what we're doing. We're playing around with model kits as an evaluation item too. And we're just going to write down the structure we want for the C2H4. To fill up everything, you have to do a double bond, right? Here's how I'm telling you guys the best way to notate. Write your double bond in the middle, and then I want you to reflect the actual geometry. It's like approximately 120 degrees from one carbon to the hydrogen, like the spacing. So your drawing should look like this. This is the three-dimensional one. This is not the Lewis structure. It's not 90 degrees. I'm trying to represent the geometry of this molecule we've done. Does that make sense? And everybody's making sense why it works like this? Each carbon has 1, 2, 3, 4 bonds. Hydrogen only wants one bond, and it's gone. The 4 bonds for the carbon means that 2 electrons per covalent bond, it's actually got access to 8 electrons. Okay, and that's important. Carbon is probably not a big mistake that carbon is what makes up life in general, because it's got so many variations possible because you can bond 4 times that the carbon compounds can be huge, sugars, starches. Well, anyway, that's enough. Now, if you haven't already, try C2H2. I'm going to just remove, and Tianji's already got it done, but I'm going to just remove this, and now I'm thinking, okay, I've got C2, and I got H2, but I don't have all the bonds. You got more springs? If you do, twisty, twisty, right? I'm going to, and this is it. There's no quadruple bonds that we study or anything like that. So triple bond, right? This is a linear molecule. It's a line, eh? You're going to draw that in. What were you going to comment on that? I'm going to go with the C triple bond. Hydrogen to the left, hydrogen to the right. Now, that reflects the actual geometry, right? It's that line. And that's important, too, for some of the characteristics of these molecules. If you want to tightly pack in your triple bond, that's fine, too. Actually, I tend to do that. Now, CO2 is the next thing, yeah. Nope. And I'll talk to you. That's just what I was going to go. So CO2. Now, usually, if you're guessing, it's something at the middle of everything. It's usually the one that can have the most bonds possible. Carbon, 4 bonds possible, because 4 singles. Oxygen only has 2 singles and 2 pairs. Before I get you up, you're wondering what the heck I'm saying. I'm saying carbon. 4 bonds possible because 4 singles. Oxygen, 6 valence electrons, so 2 singles. I'm not drawing them in any particular order. Now this is construction. So anywhere you see double, I'm asking you guys to use the blacks. The oxygens will be the ones, you're going to put 2 sticks in to just fill up those and represent where you have the lone electron pairs. O2, O2, or O2, O2 pairs of electrons. So, because a stick represents a bond, but we're going to say it also represents 2 electrons, because that's what the bond is, right? Now, 2 bonds available. Carbon, 4 bonds available. And carbon will be the center atom. I don't care if you use springs, 100%, I'm going to. Now, what's really the only way that's going to work say use springs. I don't care. I shouldn't have said I don't care. I need to use springs. Okay, just thinking symmetrically. How many bonds should attach from one carbon to an oxygen? Two. Two and two. Shares equally. So let's get this put in. And this is a representation of the reality of the geometry, I guess you could say. There, we're going to talk about the theory behind it a little bit later. But the representation is, like, stack them together. Let's see. And I need to see them because I'm paying attention as you do these. I'm going to give you marks right away, actually. So do you have this done too, CO2? I'm not giving you marks for your Ferris wheel like you just wanted. I'm just kidding. But I need, like I said, okay, get it done. You've already heard, this is sort of what we got. It's a line, it's linear. And the two sticks on the oxygens represent pairs of electrons. Well, something like that, right? Your turn. Before you mix things up, I want you to do these as Lewis diagrams where you have 90-degree angles, and we know in the models you won't have 90-degree angles. Okay? I want you to think this through. Here's what I'm going to evaluate for your lab right now. Is that you're doing Lewis diagrams with 90s. Then you're going to build it and draw the 3D thing. Remembering that I can help you. I want to see it, and then we'll draw it together. Okay? Because remember, there's a particular way to draw 3D. These ones will require, some of them will require that line coming out, the bond coming out, the bond going in. So we'll review together. So, Lewis diagrams, come up with that, then try to build it. Okay? And we're kind of doing one at a time. So CH4, start with CH4. There we go. So, you guys have this incorrectly. When you drew the model, oh, why am I clicking that? When you made the model, it looks like this. This is called tetrahedral, but don't worry about that yet. We will be. Four sides, but they're not 90 degrees. They're 190 and a half. So we got to use a 3D drawing technique, and this is why I was saying we're going to use the technique from before. I'm holding the model up like this. So I'm drawing it as if these two bonds are in the plane of the board of drawing. Okay? So I'm going to draw those ones as flat. So C, I'm going to put this one straight up, and about 109 and a half degrees down. I'm not getting a protractor, but don't make it look like it's 90. Then the other two, one goes in out of the board, one goes out of the board. To represent coming out, this, to go in the board behind the molecule. That's Star Wars kind of, you know what I meant by that? Talked about it. Like the opening scene, long ago in the galaxy far away, how the keystones out. I kind of figured that. You don't have to do the keystone like smaller stars. That basically is like a tripod with a tower on the top of what you represent. I'm going to leave this one set up here. Now, a lot of you have already worked through the next one. Tried to, but this is your chance to now do it. Keep in mind that when you're connecting nitrogen, 15th column, okay, so I know that nitrogen is probably the middle one because it's got 3 bonds available. Whichever one has the most bonds is more likely to be your middle. Chlorine and hydrogen, each one single bond. The chlorine has a bunch of pairs of electrons. So make sure you put those pairs of electrons in. 17 minus 10, 7 valence electrons. 2, 2, 2. 3 sets. 6. Okay. Can't be involved in bottom. And then the single gets it. I'll let you draw it, and I'll let you make it. Exactly, making sure that you're going to show me that for the next minute. Okay? I know. You guys are having fun with chemistry, isn't that great? Sweet treats. Okay. So, a Lewis diagram of this would have N in the center. I put these two pairs here because they can't bond. Then I know that there's 3 things to attach, so 3 bonds, 90 degrees separate. I attach, and I don't care if you put these on the left or the right, or left and right, one down, one sideways, whatever. Okay. The Lewis diagram should look like this. Of course, when you make the model, it doesn't quite look like that. So, I'm just going to, because it always depends on how you see what this represents here? The lone pair of electrons, hydrogen, hydrogen, and the chlorine, right? So the angles are totally different. What we're going to do, though, to draw it. Can I see yours, by the way? Okay. I see this.
Yeah, we made all of them.
Good. Okay. So I'm looking around, we're on the right track. So, hey, yeah, you have a red one. Sure. I did see. So to draw this, let's do it this way. I'm thinking, here's the way I think of this. This is basically the same geometry as the methane, but it's with the top cut off. So I'm going to draw a book with an N in it. A tripod bar, right? I'm going to draw it like that. So I'm going to draw it like this. Okay? Now, there's other ways to draw it, but I mean, the way I'm and the pair of electrons I want. Biology, except you don't tend to want the electrons extra. Sometimes you do, sometimes we do. So I'm going to put this one in the plane of the board, the CL. Like I said, the CLs and the H's are all, the CL singular and the H's are all interchangeable. It's really the bonds coming out or in that is important. Whether the CL is attached to the one on the left or the right doesn't matter. There's my hydrogen, out, hydrogen. So this represents basically a tripod, triangular base.
So why is it called flat?
Because this is the hydrogen, this one here is the one coming
What
out.
has to weigh has to go?
One has to
There's
go.
no way to say.
You could draw it other ways, but you'll never get all 4. Because when you try to draw them 4 flat, the red Lewis diagram, it has the wrong angle. But it's useful too for some applications. Okay. So H2S, go for it. Remembering that S is underneath oxygen, so it's going to have 6 valence electrons, 2 pairs, 2 singles. Hitch it up, you don't need springs for this one. Okay. If you recall, this is actually the same structure as water, and it's not surprising. Sulfur is right underneath oxygen. Same, like shape. So the S, I tend to always go clockwise, so there we go. You don't have to. My Lewis, I could draw my Lewis, by the way, like this. I'm not suggesting you change anything. There's nothing wrong with what you have. I could do it up and down for the H's. I could do it down and right for the H's, up and right, you know. As long as it's forward.
Why do we do the first now? Oh, yes.
What do you mean the electron? To show why the actual geometry, and we're going to get into the spaces that aren't used, they lead to why they're actually not at 90 degrees there.
Oh, yeah.
Okay, so I drew two pictures, but only one's necessary. 3D. I think of this structure when we look at our model as a variation of the first one. I'm going to say it's really just, yes, so that I can draw it flat. It's like this. Does that make sense? Every step is worth 2 electrons. Exactly. I know, you're super smart. So, S, I'm going to draw it like this. As long as you show it's not 90 degrees, it's 195. That it's actually not perfectly in this case. It's in that ballpark. So you've got to make sure they look like they're greater than 90. Okay? That's the 3D version. Not that it's coming out of the board. If I, because I can twist it like this. So I'm saying it's basically this portion of the molecule with the out and the in chopped off because those are pairs of electrons. 2 H's and it's a bent kind of shape but not 90. I could draw it coming out, but then that's more effort than you need. Okay? No, not at all. So, but I mean, draw it the simplest, but I mean, here, if you wanted to, this is an equivalent structure because watch me twist my model, right? This is the way I'm drawing. You could draw it with 2 going in. You could have the H's ups and downs. You could have chosen to draw the H's in this position, right? I'm just showing you probably the simplest way to draw these, and I'm trying to use this as my base structure for every other thing as much as possible. Okay? So that's why basically the nitrogen is just the top chopped off, the water and H2S are just the right-hand H's chopped off for that same geometry. Not the same geometry, but the same base structure that the geometry is based on. Okay. So far, good. Now HCN, I didn't include Lewis in 3D because it's the same. I want you to show me why it's the same by drawing the Lewis diagram and then making the structure. Okay. Carbon can have 4 bonds, nitrogen can have 3. So carbon's by the middle. Probably it is. Okay? You're going to involve straights because there's 4 bonds needed and only 2 things to attach. Triple bond. Yeah. You're right. Okay? I'll give you guys a minute to do that and jot things down. I'm going to go through this. Let's just talk to Andrew about this. The carbon wants 4 bonds. The nitrogen wants 3. What kind of action do we have? Triple bond. Don't use any other colors. Remember, only blacks and yellows for hydrogen. That is perfect. So, as a Lewis structure, I said it'll be the exact same as the 3D. So, the C is in the middle. Normally, you want 4 bonds. And we think of it as 4 directions for a triple bond. But the nitrogen also wants 3. So I'm going to do this. I'm going to put the electrons on the right-hand side. But I mean, if you put them on the top instead, I don't care. But I tend to just try to get them as far away from bonds as possible. And there's a reason. The hydrogen will be like this. I'm looking around good structures. Yep. Except that you're not following, you're not showing the actual nitrogen extra pair of electrons. The color. I've repeated myself several times. We are using the colors because we're showing the electrons. You get 9.5 out of 30. Just kidding. I mean, you guys are doing it. What's that? I do. I I do know my colors. But I don't really care about the colors. It's actually the structure and what the electron pairs show. Okay, I'll stop recording here.